All right, I'm going to start our last unit in college algebra. Are you celebrating on your end? I know I can't believe we're at the end of the school year already. But I want to go ahead. I did want to cover just some operations of matrices. Matrices are actually used in a ton of places in business and just for in upper level mathematics. And so I feel like just not giving you guys the real basics of a matrix would not be quite fair. And so this one is actually going to be 6.3. We're going to talk about the different matrix operations, but we're also going to add the determinant. And this is actually going to be from lesson 6.5 normally. But I'm going to go ahead and cut it down to just doing the determinants. And so we're going to cut, this is why it's called the 6.3 and then 6.5 determinants in your homework lesson. So let's get started. We used, remember, matrices to solve equations, changing it from our reduced row echelon form, and it actually can calculate equations. We did it with the 3 by 3, like systems where we had three equations with three unknowns. You can do that matrices with any. Yeah, like in other words, if I have going back to my x, just my xy, my two equations with two unknowns, I can still solve those equations with my matrix. I can also use, if let's say I had four variables, I had a w, x, y, and a z with four equations. I can also set that up as a matrix, then to put it into the reduced row echelon form and solve that. So, I mean, it really has an amazing amount of uses for matrices. So jumping in on your 6.3, notice that the first one, if I have a matrix and it's usually represented with my brackets on the sides, this is considered a 1 by 3 matrix. In other words, you have one column or one row, but three columns. One row, three columns. This is an example of a 2 by 2 matrix. And so this next one, when it's upside, when it's this way, this would be called then a 3 by 1 matrix. And then if I have matrices that are actually connected or solved together, like if they're um, put to say the x that this matrix is equal to this matrix. Each of the components or the parts are also going to be equal to each other. For instance, if I'm solving for x, if x is in my position of 1, 1, my row 1, column 1, then it's going to be equal then to row 1, column 1 on my other matrices. So in this case, x is going to equal then 6. I could also do the y the same way, but this times 3y is in the position of one row, column 2. So it's going to be then 3y is going to be in the same position as the 3. So 3y equals 3. And then I'd want to go ahead and solve for y by dividing both sides by 3. So y is going to equal 1. And then my z is going to be in the same position as my 15. So then z is going to equal 15. We can also add and subtract matrices and also take them times a scalar. So when I do that, the first time when I add A and B, what I'm really going to do is add the same parts. So in other words, 9 is in the same component as -7. And since I'm adding them, I will have 9. It's actually like plus a -7 in this position. Then 8, I'm going to add to -2. So it's going to be in the position of 8 plus a -2. Then I'm going to go 7 plus 0. I'm going to have then 3 plus a -8. Continue with -3 plus a -7. And then I'm going to also have then 2 plus 6. And I would not want to leave that, but that's how you're going to calculate the numbers for your matrix. And so my answer then would be like 9 minus 7 would be then 2. I have 8 minus 2 is going to be 6, 7. 3 plus a -8 is -5. And then I'd have a -10. And then I'd have 8. So this would be the addition of A plus B if my matrices are defined as these two. A minus B works the same way, except on this one, I'm going to have 9 minus a -7. I'm going to have 8 minus a -2. 7 minus 0, 3 minus a -8. And I have -3 minus a -7. And then I'd have 2 minus 6. So my answer for the subtraction would be then, I'm going to add these. So 9 plus 7 would be then 16. I'd have 8 plus 2 is going to be 10. I would have 7. This would be 11. And then I'd have then -3 plus 7, which would be 4. And this would be then a -4. I can also multiply matrices times a constant or a scalar. So in this case, if I'm multiplying it times a -6, then I'm just going to start off with, I'm going to multiply a times a -6. That means I'm going to have a -6 times 9. I'll have a -6 times 8, -6 times 7, -6 times 3, -6 times -3, and -6 times 2. It took me more to write it out than it did to actually do it. So I have then, again, the -54. I'd have the -48, a -42, a -18. I'm going to check to see if I know my multiplication tables. This one is going to give me a +18. And then I'm going to have then a -12. Okay, so again, order matrices, we can do that. If I flip over on my next problem, and it kind of squeezed it up here on the top. So it's -2 minus 4b. So in this case, that means I'm going to multiply 2 times a and multiply 4 times b and then subtract them. So let's go ahead. If I'm going to just really quickly do that, notice I did not do it really well. I should have had that on the same page. So 4 is 9, 8, 7, 3, -3, 2. So it's going to be 2 times that. So it's going to be 18. 8, 16, I think I had 14, 3, I think was the next one, 3, -3. So 3 times 2 is going to be 6, -6, and then 4. Double check. And then on that one, that would be then, this is going to be 2 times a. Then if I had then 4 times b, I'm just going to go ahead and write my b the same way. If I can remember how to do that one. So -7, -2, 0. So I'd have then -7, which times 4 would be -28. Then I know what that one was 0, -2. I think it was 8, -2. So I'm going to go -8. And then I would have -8, -7, and -6. -8 would be then times 4 is 32. -7 is 28. Or times, yeah. And then -7 times 4. And then 6 times 4 is 24. There we go. And then I'm subtracting them, then I would do the same thing. So I would end up going ahead and just subtracting them just like normal. I'm going to show you. Notice you probably noticed I have a matrix calculator up there, and I gave you that link. I'm going to go ahead and put my A, B, and C in there, and so I'll have this. And in order to do this, I've got a matrix already there, but I can go ahead and just copy over the numbers. I'm going to arrow over to change them to 8, and then I can go down and over or return. So to get my next one, the 3, I would have 7, 7, and then 3, and then I'm going to hit a return, and it'll give me another row. So then I would go -3, and then 2. My matrix B, I'm going to do the same thing. So I'm going to go -7, arrow over, -2, come down and over, it doesn't like to come over, 0, -8. I'm going to hit return to give me another row, and then I'll have -7, and then 6. So if you remember, we did all of those operations that we had before. So I can go ahead and just check my work. I can put them here. I can actually go A plus B, what we did the very first one, and then ask it to compute, and it's going to tell me my details of what I got. And so if you notice, that's the same thing that I had earlier. I can also go A minus B by just changing that and then asking it to compute, and then it should give me the same answer that I had earlier, unless I had B minus A. B minus A would be opposite. So on this one, if I did on my homework note, I had A minus B, and then I'd have to tell it to compute. And so notice that I get the same answer that I got before. I can also do that same one that we were working on. So I had the 2A minus, and then it said was 4b, and ask it to compute, and it's going to also tell you your steps to how to solve that. And so in other words, we started off, remember, this was the 2 times that, which was the 2, 14, -6. We can just check to make sure I got it right. And then again, I had, whoops, I had a negative, so this one I need to make sure I changed to positive. And then 0, then 28, 8, 32, and goodness, let me go positive here and then a negative here. So then it would actually then subtract this too. So again, you can use your technology and to get these as well. And so I want you to make sure you understand how to find out the technology. Now, multiplying is a different animal. Okay, so when you multiply matrix, what you're going to be using is what they call a dot product. And dot product actually is used in like our vectors. If you take like a trigonometry class later, you're going to learn dot product by combining a component with your vectors. Dot product in this case will for matrices mean that you're going to multiply, like if I have to, and if I'm multiplying my matrices together, I'm going to use the dot product to find the answer. So in other words, when I have a row, if I have in this case, this is going to be then the 2 by 3, and then this one's 2 by 3 and a 3 by 2. So we have to take the first row times the first column. And so if you notice, if I have 1, 2, 3 in my first row, but I have 7, 8, and 9, then I'm going to multiply 1 times 7, 2 times 9, and 3 times 11, and then add them together. And that'll give me one answer of 58. So in this case, if I have to make sure that my outer terms, like this one is going to be, starts with a 2, and this one ends with a 2, so it's a 2 by 3, and then times a 3 by 2. They have to actually, I have to have the same components. So I have to be careful on when I can multiply matrices together. And I'll show you that with an example as we go to my matrix calculator. So in this case, I'm going to show you how to do it the long way, and then we're going to find DC just the short way. So to find CD, I'm going to start off with using my dot product. So I'm going to take 1 times 5, and I'm going to add it to 2 times 7. Here's also another example, like it's A11 is what they're doing. They have 1, 1, 2, 1, 3, 1, and then 1, 2, 2, 2. So in other words, A11 is also times B11. And then A12 is times B21. So this one, I'm going to have that'll be my first number when I say it's equal to. So I have 5 times 1 is 5 plus 14 would be then 19. And so for my product, let me just go ahead. I'm just going to do it this way. I'm going to put a 19 here rather than in here. Let's show how to do that though. So on the next one, I'm going to take this one. So my next column would be 1 times 6. So it's going to be 1 times 6 plus then 2 times 8. And 6 plus 16 should give me 22. Then I'm going to take 3 times 5 plus 4 times 7. And then 3 times 5 would be then 15, and 4 times 7 is 28. And so that would give me then 33. And then the last one, I would go 3 times 6 plus 4 times 8. And 3 times 6 is 24, 4 times 8 is 32. And so that should give me a 56. So then if I put those in my matrix calculator, so let me go ahead and do it. Notice I'm going to have, I need to change it because I want to make sure that I have like a 2 by 2 matrix. So you can just use your add and subtract buttons to make it work until you get that. And as long as you have one, as soon as I go to the next, I'm going to tab over, it'll put it in. So I'm going to go 1 tab and it puts another one in as 2. And then I'm going to go 3 and 4. That's a matrix A. I'm going to also do the same thing with B. So I'm going to show you this one. It'd be 5, 6. Whoops, I don't want that. So I'm going to delete. I'm going to go minus that. But I'm going to go ahead and return. And then 7 and 8. And I'm going to ask it to compute A times B. And so that's again where you can see, oh, did I add something wrong here? I sure did. 43 plus 15 plus 28. I forgot to carry, so that is going to be a 43. So I did make an error right there as 43. And did I do this one wrong too? Oh, 3 times 6 is not 24. That's 18. Donna. Oh my goodness. So that's part of the reason I like to use my matrix calculator is because I do tend to sometimes make silly computational errors. So my answer actually, when I multiply it, is it's going to be this. If I wanted to go B times A, I'm going to actually get a different answer. So I'm going to go ahead and just plug it in here because I'm going to change it. So I'm going to just type in B, and then I'm also going to go times A, and I'm going to ask it to compute. And so when I multiply my D times C, even though it's different variables, I'm going to get then 23, 22, 43, and 50. Now, when I do what we call the determinant, and a determinant is actually used in quite a few places in math to find, like we can actually use it to solve some equations. We can also use determinants within the matrices. So it's a common term that we use. When I find the determinant of my matrix, it has to be a square matrix. So if you notice, like all of the ones I've had so far, like the 2 by 2, this one is not a square matrix because it's a 2 by 3. All of the ones we used yesterday when we solved those equations, those were not square matrices. But if you have a square matrices, you can determine the determinant. And the determinant is just found by going diagonally, multiplying the answers. So like in this case, I'm going to go diagonally A1 times B2, and then I'm going to subtract it from the other direction, which is A2 times B1. So I'm going to start over here. I'm going to go down. You always go down first. So in other words, I'm going to go down, and that's going to be then -1 times 1. And then I will subtract, and I go this way, and then I pull it here. So I'm going to go then 8 times 2. So -1 times -1 is a -1 minus 8 times 2, which is going to be 16. And so my determinant is going to be -17. Um, I can do the 3 by 3. I can do any matrices that's square. But in order for me to get to a 3 by 3, it's a little more complicated because what you're going to need to do is you kind of need to you subtract those out, and it's actually this formula. But let me show you. It's also by crossing out the rows and columns, you have that matrices left, and then you're multiplying it times A1. So in the next one, I'd cross the next row out, and I'd have B1 over B3, C1 over C3, and then I'd multiply it times A2. And this is how they derive that formula. And this formula works for any square matrices. Okay, so in other words, if I have a 4 by 4, if I have a 5 by 5, it still will work the same way. What I like to do on my 3 by 3s is actually doing kind of the same thing, but I do a shortcut. In order for me to do my diagonal going down, I can do the first one, but notice I can't on the second one because I'm missing a spot. In the 3 by 3s, you can actually go 5, 3, -6. In other words, you're repeating this column. So repeat column 1, and you repeat column 2. So it's going to be 5, 3, 5. And then you can do your matrices just like we did before with the 2 by 2. So again, I'm going to go diagonally going down. I'm going to go 5 times 3 times a -1. Then I'm going to actually add this one together. I'm going to add this whole group until I get to the very end. So I'm going to go 5 times 3 times -1, but then the next one, I'm going to add 5 times 3 times -6. And then I have my last one, which would be then plus 5 times 3 times 5. Okay. Then this part is going to be subtracted by going up. So I'm going to start off here, and remember I put that here and I go over on the other side. So I'm going to have then -6 times 3 times 5 plus, I'm going to go this direction, 5 times 3 times 5. And my last one I'm going to have then would be -1 times 3 times 5. And this whole thing, I need to add these together before I subtract them. Okay, I told you I was going to show you an easier way. So let me go back. I'm going to do matrix A. Matrix A. I'm going to go ahead and put my matrix back in. I'm just going to do the 3 by 3. So the first row is 5. Whoops, not 15. 5, 5, and 5. My next one is 3, 3, and 3. As I write 5 and 5. Come on. Okay, let me try again. 3, 3, and 3. I'm going to hit return, so I have another row. -6, 5, and then -1. Okay, if I want to find my determinant, I have a button that I go ahead and click, and so I'm just going to ask for the determinant. And so what happens is you're going to end up with then this whole thing then is going to equal then 0. So my determinant is equal to 0. On the problem that I had before, if you remember, I had just the 2 by 2. So let's go ahead and practice that one just with my matrix B. And we'll check to see if I have the right answer. -1, I'm going to come over and go 2. And then I'm going to go 8 and 1. And then I'm asked to find my determinant. And so when I did my determinant, we had then is -17. And they will go ahead and give you the details for that. Okay. Hopefully you did well. All right, so you have 6.3. It's called 6.3. And then it's with some words, and then 6.5 with determinants that you will have on your homework, and that's it. Next week we'll be working on chapter reviews, and then we'll be taking the chapter test at the end of next week, or kind of in the maybe Thursday, Wednesday, Thursday. All right, have a great day.